2, linear relations and functions. In this lesson, we're going to talk about the very specific type of function in relation called a linear relation. So what is it? It's a function a linear function is a function whose highest power is 1. So something like this, something like this, something like this, all that. Highest power in all these right here is the power 1. Now this doesn't have a power. It's x to 0, but we say it's plus 0 x to the 1 power. So it's a linear function. Why? Because when you graph it, it's a line that has a Virgo line test. That's why it's a linear power. So if it's just a y equals number, it's still linear. By the way, x equals 3, not linear function. Why not? It's linear, it's just not a function. It doesn't pass the Virgo line test. So that's why it's not a linear function. So it is a linear, just not a function. So that's a linear function, that's a linear function, that's a linear function. Key with all these, highest power is 1. I didn't mean to cross that out. Anyway, real quickly, let's do some examples. Now here, that we could break this up to make it a little easier. This is x over 5 plus 12 over 5. Or if you want, 1/5 x plus 12 over 5. And yes, highest power, it's a linear function, highest power is 1. So yes. Yes or no? This one's not. Now look, I can break it up. I get 7 over x minus x over x. You might say the highest power there is 1, but it's on the bottom. We haven't really talked about this yet, but what happens there is it becomes a negative on top. So we want only power 1, not negative 1. So this is not a function. This one, highest power is 2, so no. Highest power here is 1, so yes. So only tricky one was that one, right? If it's the first power on the bottom, that doesn't count. It has to be on top. Now, one of the main things to do with linear functions is rewrite equations. So look at this problem here. You want to make sure that you have enough music for a card trip. If each CD is an average 45 minutes long, and the linear function mx equals this, linear because highest power is 1, can be used to find out how many CDs you need to bring. Now, they should tell you more information. X here is CDs, and M is minutes. Actually, I think M is hours. Yeah, because they don't. At 0.75 is 3/4 of an hour, and 45 minutes is 3/4 of an hour. So M is hours. Yeah, not very good. Here we go. How many hours of music do you need? Again, they should give you more. They didn't give you enough information here. How many hours of music are there in 4 CDs? So notice they gave us CDs. That's what X is. We're gonna plug it in for X. Very simple. So they want to know, hey, if you have 4 CDs, how many hours of music is that? That's about, if you multiply that out, you get about 3 hours. So 4 CDs is 3 hours. Now look at B. If the trip you're taking takes 6 hours, now they're giving us hours of music. So they're giving us M this time. How many CDs do you need to bring? So now we're gonna have 6 equals 0.75x. Right, we're gonna plug the 6 in for the M part right there. So this is our equation. I'm going to divide both sides by 0.75. I get x equals 8. So we need 8 CDs in that case. So let's look real quick at understanding that if I give you an equation, you got to understand what the 2 variables are. Right? In this case, x is CDs, M is hours. So when they give us CDs, you plug it in for the x. They give you hours, you plug it in for the M. Now let's talk about the standard form of a linear function. So here's the standard form of a linear function. X and y are on the same side. It's just this right here. That's the standard form. Now if you want to be technical about it, I think they want the x to be positive, but honestly, standard form just means x and y are on the same side and the constants on the other side. So the variables are on one side, constants on the other side. So they want to write each statement in standard form. So all I gotta do is move that x over. So I can move that over, subtract 6x from both sides. I get negative 6x plus y equals 5. That's standard form. Right here, a would be negative 6. B would be 1 if I want the coefficients, right? A, B, C is just the coefficients, so the number in front of the variable. So a would be negative 6. B would be the number in front of y, which is this 1, and then C would just be 5. Again, that's standard form. You could also have done it the other way, where you move the y over and move the 5 the other way, and you get something that looks like this. right? And subtract the y from both sides, subtract the 5 from both sides, you get that same thing. Doesn't matter. So real quickly, let's put this in standard form. I'm actually going to add 8x both sides this way. I don't like working with negatives. And then plus 6. So I'm going to get, people are going to be mad at me the way I wrote that, but whatever. 6 equals 8x plus 9y. Technically, we probably should put it on this side, so it looks like standard form. But it's the same thing. So there we go. That's my A, my B, and my C. Hey, this is already in standard form. A, B, C, done. Next. Graph a linear function using intercepts. Okay, this is important. Let's talk about it. Do this. Let me try some of my new things here. Here we go. Let's see how this works. Oh yeah. So there's my XY chart. Like that's green. So this is X, and this is Y. In case you didn't know. So let's talk about what X and Y intercept is. So if I draw a line here, where it intercepts the x-axis, where it crosses, it's called an x-intercept. Now think about it like it's a point, right? Let's say this was a point 2, 0. Notice how the y is 0. When you have an x-intercept, it's x is x, and then the y value is 0. Because that's why you're crossing the x. So if you want to find x-intercept, all you do is set y equal to 0. Likewise, if you're trying to find the y-intercept, right here, right, where you accept the y-intercept, where you cross the y-axis. If you look at that point there, it's going to be some y value, but x is 0. You haven't moved, so it'll be 0y. So if you want to find the y-intercept, you just set x equal to 0. So it's just the opposite. You want the y-intercept, set x equal to 0. You want the x-intercept, set y equal to 0. That's all it is. So let's do it here. Find the x and y-intercepts and then graph each equation. So let's find the x-intercepts. So I think you're going to do a lot over the next couple of years, find the x-intercept. So all we're going to do is plug y in for plugging 0 for y. So I get 0 equals 5x plus 12. Subtract 12 from both sides. Negative 12 equals 5x. Divide by 5. Negative 12 over 5. And I'll round it. Negative 1. Negative 2. I can do math. 2.4. Whew. Okay. Y-intercepts. Easier one, generally. I'm going to set x equal to 0. Right? It's always opposite. That says x equals 0. So we're going to plug in 0 for x, sub it in. And that says 0, and I get y equals 12. So my x-intercept should be, I should write this the proper way. My y-intercept should be 0 and 12. My x-intercept should be negative 2.4 and 0. It's a point, right? Because this is my x value and my y value is 0. If I want to graph this, just go to those points right there. Negative 2.4 and 0. Probably should use the tool again, but whatever, we're here. And then graph your y-intercept, 0 and 12. Let's say it's way up here. Then you can just connect the dots much better than I can, because I tell you, this is not the easiest thing to do in the world. That isn't too bad. There you go. By the way, to function, it's 1-to-1. So one more time, let's make sure we got this and make sure I can do my math correctly. Right, so again, if I want the x-intercept, I'm just going to plug in 0 for y. So that's like right here. So it'll be 2x plus 3 times 0. That just goes away. I get 2x equals 12. X equals 6. So it's going to be the point 6, 0. Because I plugged in 6 for x, and I get 0. If I want the y-intercepts, we're just going to plug in x equals 0. So 2 times 0 plus 3y equals 12. That just goes away. 3y equals 12. Divide by 3. Y equals 4. So again, my point would be 0, 4. Right, I plugged in 0 and I got 4 for my y. So if I'm going to graph it, man, I should use it. Well, whatever. I'm here. Right, 6, 0. Let's go 1, 2, 3, 4, 5, 6. There we go. And then 0, 4 for my y. So 1, 2, 3, 4. And again, all you do is connect it. Something like that. And there you go. You got the graph. Again, hey, notice 1-to-1 function. Okay, last thing. So another application problem. The speed of Steel Dragon 2000. Roller coaster in Mi Prefecture, Japan. I said that correctly. Can be modeled by y equals 10.4 x, where y is the distance. Like, this is the equation, right? They tell you, hey, y is the distance traveled in meters, and x is in seconds. So that's what they should do every single time. So you have this equation, and we know exactly, hey, x is seconds, how long it's been, and y is how far you've traveled. in meters. So the question is, how far does the coaster travel in 25 seconds? So A is easy. I'm like, okay, they gave me seconds. All I gotta do is plug it into the equation. Right on. So you plug this in. We plug into our calculator. Here's my fancy one. Let's see, 10.4 times 25, and I get 260. So remember, it's meters. 260 meters. It travels 260 meters in 25 seconds. Okay, let's see B. The speed of the Kingda Ka roller coaster in Jacksonville, New Jersey. Jackson, New Jersey can be described by the equation y equals to 33.9x. Which coaster travels faster? Explain reasoning. So lots of ways you can do this. I think what they want you to do is this: go, hey, I know how fast this travels in. I know how fast the first Steel Dragon 2000 travels in 25 seconds. How fast does Kingda Ka travel in 25 seconds? So you do that. That's one way to do this. 33.9 times, which, I mean, it's kind of obvious what's going to win, but whatever. I'm going to go through the show. 847.5, that's a lot. Go America, I guess. So you get that one. So yeah, Kingda Ka wins because it travels longer in the first 25 seconds. I think most of you guys probably noticed also just like, hey, the slope, which we haven't learned yet, is bigger on the Kingda Ka roller coaster. So that's another reason why that one's faster. I've actually never been to Kingda Ka roller coaster, but I have been to the Steel Dragon 2000. That's what the final picture here is. It's my trip to the Steel Dragon 2000 in Japan. It was a good roller coaster. Anyway, that's it.